All right, so now I need to apply some networks, some IP addresses on here. So I'm going to use green, and one network is going to span from here to here. So everything inside this green shape will be one network. And then I'll use brown here, I suppose. And these serial interfaces here will be in a network. And then we'll have a third network. I'll do green over here. In this particular case, I'm using my switches as just pure layer 2 switches. So they are just extending my broadcast domain. And if you're not familiar with that term broadcast domain, I talk about that in my CCNA videos as well. Okay, so I need 3 networks. So I have to ask myself, okay, so what network addresses do I want? Remember, in my IP address, the first portion of the address is going to be common among all the people in that network, all the devices. And the second portion of the IP address is going to be unique for each host or device or each NIC card connected to that network. It says, does the WAN provider determine the clock rate? Typically, yes. Typically, the actual WAN provider you're connected to, they would provide clocking to you, the customer at the other end. So let's just do it easy here. Let's just say that this is going to be the one network. Let's say 111 network. And let's say that this over here in brown will be the 222X network. And over here in green, we'll have the 333X network. Okay, so the laptop is going to be generating packets and expecting to receive packets. So because he's creating packets from scratch, and because packets will be coming back to him, which he needs to read, he needs an IP address. Now his IP address, I will give it to him via DHCP. Because in normal networks, you know, when you turn on your laptop, you don't configure an IP address on your laptop. It just magically gets one. And it gets one via the dynamic host configuration protocol. Well, if he's the host, there has to be a DHCP server that can give him his IP address. And so I'll make that as router 1. DHCP server. All right, we'll do that in a second. Now the switches, they don't need any IP addresses. Now if I want to telnet to them or ping them, they should, but for the purposes of this lab, to make it simple, I'm not going to do that. They're just forwarding Ethernet frames. They're not doing any network layer stuff. So the only static IP address I'm going to put in network 1 is going to be on my router. So I'll give this interface right here. Why don't we give him the last IP address in this network, 111.254. And here in my WAN cloud, I've only got 2 devices connected. So we'll say this guy can be 2221/30, and this guy can be 2222/30. Now if you're looking at this and you're starting to get confused over the IP addresses, once again, for the purposes of this class, just know that the Internet Protocol, which is the protocol used to transmit data from your computer to another computer, requires that both sides of the connection have a unique address called an IP address. The actual format of that address, I get into detail in my CCNA videos, and we just don't have time to go into that in this class. And then here, I need 2 addresses in the 333 network. So why don't we have this be 333.1? Actually, let's just keep it consistent. .2, because that is router 2 after all. And this right here is router 3. So let's make him 3333. And once again, I'm going to configure those IP addresses on these interfaces. The router itself does not get an IP address. His interface gets an IP address. Okay. All right, so I've got my IP addressing scheme done. So let's go ahead and configure that. I'm going to move this whiteboard over here to a different screen so I can reference it. Okay, so switch number 1, switch number 2, they don't need IP addresses, so I just need to start configuring stuff on router number 1. So that is session 3. All right, so first of all, let's give him a host name so I recognize that he's router 1. I don't get him confused with anybody else. Let's go into my fast Ethernet interface. IP address 111.254. Let's make sure that interface is up and enabled. All right. And now let's go into my interface serial 010. Give him the IP address I assigned of 2221 with a different subnet mask. Okay. And before I leave router 1, I need to configure him as a DHCP server so my laptop can actually get an IP address. So IP DHCP pool, let's just give it the name of INE. And as a DHCP server, he's going to need to be handing out IP addresses in the 111 network. So I'll say network 1110. And he will be the router that everybody in that network uses to get to other networks. When they need to do web page lookups, they'll need a DNS server. We'll just make that him as well. And any DHCP addresses that he allocates, let's have them be good for 12 days and 6 hours. All right, so with that, all by itself, that should be enough for my laptop to now obtain an IP address via DHCP. Let's see if it has. Bring up my DOS prompt. Okay, with my DOS prompt up, I'll say IP config. Okay, so my Ethernet adapter, as we can see here, has not gotten an IP address. It defaulted to the automatically provisioned IP address of 169, but it should have gotten an IP address of 111. So let me go ahead and sort of kickstart DHCP. All right. That looks better. There we go. Ethernet address. It was given the first address in that range, 1111. And so now to prove that he has network connectivity, I'm just going to issue a ping to 111.254. See if I can ping my default gateway, which I definitely should be able to. And I can. I can ping my default gateway. Okay, so my IP addressing is done on router 1. Let's go over now to router 2, and let's just finish off my diagram here. Give him a unique host name, and we'll go into interface serial 010, IP address 2222. Okay. Make this a little bit larger here so you guys can see it better. Okay. And then, actually now I can't see my whiteboard, so that's not going to work. And then let's leave that interface and go into his interface fast Ethernet 0/1. Maybe I can just do this. Let's make the font a little larger. There we go. IP address 3332. Oops. No shutdown. Okay, I don't need to put an IP address on switch 3. So now let me go to my web server, which in reality is router 3. Ah, okay, so show run. Do I have something for router 3? I do not. Ah, but I have it as server. That's why. Okay, so server. Remember, router 3 was connected to octal cable connection number 6. In just a moment here, I should be given access to his command line. There we go. Just need to stick an IP address on him. Interface fast Ethernet 0/1, IP address 3333. Okay, so if I've done everything correctly here, if there's nothing that needs to be doing any troubleshooting, from my web server of 3333, I should be able to ping 3332. Let's confirm that I can. There we go. Ping was successful. And if I go over here to router 2, he should be able to ping the other side of the serial connection, which is 2221. And he can. Now, I'm not done yet, though. Here's the problem. Right now, the laptop has learned via DHCP. Let's go ahead and put his IP address up here now that he's got one. He is 1111, and his default gateway is 111.254. So if I brought up my browser, and in my browser I said, hey, give me the website of 3333. Let me see the web page that 333 is hosting. The laptop would say, well, he'd compare his source address of 1111 with the destination address of 3333, and he'd very quickly realize, oh, you want me to talk to somebody who's not on my network, who's not in this green box here. Say, well, if I want to send packets to someone who's not on my network, the only person I can send them to is my router, my default gateway. So he would send his web browsing packets to the router, saying, hey, router, can you forward these packets to 333 for me? Here's where we'd have the problem. The router would get those packets. He'd look at the destination address of 3333 and he'd say, that's not me. I don't have an IP address of 3333. And he'd look around in his routing table and he'd say, well, do I know how to get to 3333? Right now his answer would be, no, I don't know how to get there. The only networks I know about are the networks that I live on. I live on the 111 network and I live on the 222 network. I have no idea where the 333 network is. So I have to enable routing here. I have to enable router 1 to learn about the 333 network, to know that he goes to router 2 to get there. And conversely, I need routers 2 and 3 to learn about these remote networks. I need router 2 to learn about the 111 network. Otherwise, he won't be able to reply to those packets. And router 3. Router 3, the only network he knows about is the 33 network. He needs to know about these other ones. Now, if router 3 was really a web server, if he was really a computer, like my laptop, he wouldn't be doing routing. Just like my laptop, he would have a default gateway saying, hey, to send packets to anybody who's not 333, send it to 3332. So because he's a router, I'm going to configure his default gateway with what's called a static route. So I'm just going to say IP route. That means any packet where you don't know where it goes. If you receive a packet and you have no idea where the destination goes, send it to 3332. That's like giving him a default gateway, but this is putting a route in his routing table. All right? So that's all I need on the web server. And what I'm going to do is I'm just going to enable routing between router 1 and router 2. I'm just going to configure some routing protocol. Let's configure RIP as an example. And a routing protocol, in case you're not familiar with that term, that's a language that routers speak between each other, where router 1 can say, hey, router 2, you and I both know about the 222 network because we sit on it, we share it. But you probably don't know about the 111 network. So let me tell you about it. Router 2, you can get to the 111 network through me. The routing protocol will do that. And similarly, router 2 will say, hey, thank you, friend. By the way, you probably don't know about the 333 network. Let me tell you about that. And hey, router 1, you can get to that network through me. So routing protocol is a way for these routers to dynamically speak to each other and exchange routes. So I'm just going to use RIP. RIP is very simple to configure. So I'm going to go on to router 1. I'll say router RIP. We'll use RIP version 2. No auto summary. It's all part of my CCNA stuff if you want to learn more about RIP. And then I will just activate RIP on the 111 network and the 222 network. So with RIP, all I have to do is network 1 and network 2. And then similarly, I'll go across to router 2 and do something the same. Router RIP, version 2, no auto summary, and he's connected to the 2 network, and he's connected to this network right there. And with that, I should now have end-to-end IP reachability. Router 2 should now have learned via RIP about the 111 network. Let's verify that. And he did. He's got a RIP route to the 111 network. And similarly, router 1 should know about the 333 network. And he does. So as it stands right now, from my laptop, I should be able to ping 3333 and get a response. Let's see if I can. Where's my DOS prompt? There it is. And I'm getting a reply. Okay, one last step I need to do here. I need to go into my router. Where is that whiteboard? Here we go. I need to go into router 3 and configure him to offer a web page. By default, routers and switches, even though they have the capability of offering a website, so you can configure the router or switch with a website, it doesn't do that by default. So there are some lines of configuration commands I need to put in to give him that ability. So that being the case, I'm going to go into router 3. Let's get out of this, which is my server. The commands to do that are, first of all, IP HTTP server. That says I want to activate you for web serving service. Now the HTTP server will only serve up a web page if someone authenticates themselves. In other words, when my laptop tries to get to the web page of this, my laptop is going to be presented with a username and password prompt. So I have to configure the router here to know how to respond to that. And there's a bunch of commands for that. So this command right here is saying, okay, when someone provides you the authentication credentials, when they provide you a username and a password, look on yourself. That username and password should be stored locally right here on you. You don't have to go any further. Okay, so where is it? Let's create it. Let's say username Keith. And Keith is going to be given access to privilege level 15 commands, which means when Keith logs in via the web browser, he can access any command that he would normally be able to access via the command line. And Keith is going to have the password of Cisco. All right, so there's a username and password. So in a real world, your network admin, you would provide a username and password for the network admin at your company. And then we're going to go AAA new dash model, AAA authentication, login default local. So this says when somebody tries to log in to the CLI of this router, the default behavior is to look locally for the credentials. Okay. And AAA authorization, exec, default local. Not going to go into a lot of details of AAA because that's way above and beyond the scope of this particular class. So that should do it. Now I should be able to go to my laptop, open up a browser, let's make this a little bit smaller here. And in my browser, let me go ahead and zoom in on that. I should be able to say http://3333, that is the router. There we go. My username is Keith. My password is Cisco. And there we go. I have full end-to-end network connectivity, and right now I am on router 3. So I have built this network from scratch. I've cabled it up. We've provided IP addresses, some minimal routing, DHCP functionality, configured this router to act as a web server, and we have verified that we have end-to-end connectivity between the laptop and the router. Okay, well with that, I'll go ahead and bring us to a close. Thank you very much for watching today. And if you are going to pursue a Cisco certification, I wish you the best of success, and feel free to reach out to me with any questions that you might have. So thanks a lot and good luck.